Okay, picking up where we left off. At number 9, a regression analysis of company profits and the amount of money companies spent on advertising found an R-squared value of 0.72. Which of these is true? The model can correctly predict the profit of 72% of companies. Is that what R-squared tells us? No. On average, 72% of a company's profit results from advertising. It's also not it. Non-average companies spend about 72% of their profits on advertising. You should think about R squared as the math lib that I gave you. That's 72% of the variability in the amount of money. I'm sorry, in their profits. 72% of the variability in their profits would be attributed to the amount of money companies spent on advertising. So I'm going to go with none on that. Number 10, ending out the multiple choice. A least squares regression line has been fitted to a scatter plot. The model's residuals plot is shown, which is true. Linear model is appropriate because you see random scatter. Or you could also justify that with no discernible pattern. Everything else, curve model, no. Obviously not, none of the above. The linear model is poor because correlation is near zero. You're not looking at correlation in the residual plot. Linear model is poor because some residuals are large. Yeah, some are large, some are not. That's fine. Random scatter is appropriate. Let's go on to number 11. A college's job placement office collected data about students' GPAs and salaries they earned their first jobs after graduation. So first of all, it's saying maybe salary would be a Y and GPA would be an X. Mean GPA, so X bar would be 2.9 with a standard deviation of 0.4. Starting salaries had a mean of 47,200 with a standard deviation of your Y, 8,500, and an R of 0.72. So write an equation that can model. So you want some type of Y equals A plus BX. Remember, slope is R times SY over SX, or 0.72. You might want to pause this. I'm going to go through this a little fast, but SY is 8,500. SX is 0.4. Throw that all in a calculator, and you should get 15,300. Or for each point in that you increase in GPA, you'd be going up a starting salary of over 15,000. Y-intercept, remember, is Y bar minus slope times X bar. Those will be given to you on the test. So 47,200 minus 15,300 times 0.4, Y-intercept of 2,830. Throw it on a calculator. So we have a slope, we have a Y-intercept. Build the equation. So starting salaries predicted, 2,830. So if you have a GPA of 0, 2,830 would be your predicted salary. Although I'm not sure that makes a whole lot of sense because they just might not be hiring you. Times the slope times GPA. Okay. Do you think these predictions will be reliable? A question like that is kind of asking us about correlation. So I'd say possibly due to moderate correlation. But if you look at an R squared value, like if R is 0.72, square it, R squared is 0.52. So you would say only 52% of the variability in salaries can be attributed to variability in GPA. You can either comment on correlation or comment on R squared. Since I only have so long on this video, I'm not going to write it all out. Your brother just graduated from that college with a GPA of 3.3. Not bad, dude. He tells you that based on this model, the residual for his pay is negative, so that is not as cool. What salary is he earning? First, find out what was predicted, then take away the residual. So that means we'd start with 2,830 minus plus the 15,300 times his GPA. Throw that in the calculator. That's 53,320. Take away his residual. Do all that. His actual salary is 51,440, which is less than his predicted salary. Bummer, man. All right, number 12, assembly line. Your new job at Panasonic is to do the final assembly of camcorders. As you learn how, you get faster. The company tells you that you'll qualify for a raise if after 13 weeks your assembly time averages under 20 minutes. The data shows your average assembly time during each of the first 10 weeks. What's the explanatory variable? How long you're there. In weeks, probably somewhat predicts how long it takes you to do this. What's the correlation? Throw all this in a calculator. List 1, list 2, find your linear regression line, and it'll give you an R and R squared, but it'll tell you the R is negative 0.97. You want to predict whether or not you will qualify for that raise. Well, that means 10, 11, 12, 13. Is that time going to be under 20? Like I said in B, find your least squares regression line in the calculator. You should have something like predicted time is 4207 minus 181 times the amount of weeks you're there. Would it be you want to predict? So actually now times the amount of weeks. We asked 13. Plug that in, and it says 1854. So answer the question. The company tells you qualify for a raise after 13 weeks if your assembly time averages under 20 minutes. Are you under 20? Good, you're under 20, you qualify for the raise. Now, actually look at the rest of C. Would it be appropriate to use a linear model? So I told you just on a list page, get this. Remember, you have to look, are there two quantitative variables? Yes. Is it straight enough? Probably. That's a pretty strong correlation. However, when you look at the residual plots, there's going to be a distinct pattern or a little bit of a curve where you see it go as a real curve there and a bit of a dip there. There's a strong pattern, and you probably have to say, no, the curve in the residual plot tells us not to use a linear model. Okay, so even though the regression line told us that you would be under 20, we probably shouldn't use a regression line due to the curve in the residual plot. I didn't print 13 for you. I didn't print 14 for you. So 15, gas mileage again. In the data desk lab last week, you analyzed the association between a car's fuel economy, which is miles per gallon, versus its weight. Another important factor is the amount of gasoline a car uses is the size of its engine. So called displacement engine size. I only have a couple seconds left on this one, so we'll see where I cut it off. Called displacement engine size measures the volume of the cylinders in cubic inches. So regression analysis is shown. How many cars were included? You really have to read through a lot of this. Just in the second line, it says 89 cases. Correlation, well, it gives you R squared is 0.609, so take a